So welcome back. Again, we're going to solve this system of equations by using the substitution method. And again, we have to choose which equation and which variable we want to solve for. I really don't like this bottom equation because of that 7. They look a little harder to deal with. I do like this top equation, and just to go a little bit differently, I'm going to go ahead and solve for x and just see what happens here. So I'm going to have this, I'm going to write that down here. Negative 2x plus 6y is equal to 6. Again, to solve for x, this 6y is going to go to the other side. And remember, when it goes to the other side, all it's doing is changing sign. That's our shortcut. So negative 2x equals then a negative 6y plus 6. That can save me some writing. And to get rid of this negative 2, I've got to divide everything by a negative 2. So that becomes x. Negative 6 divided by negative 2 becomes a 3, so it's 3y. And negative 6 divided by negative 2 would be then a minus 3. So I can divide all that by a negative 2. Again, I don't actually have to show that. I can merely do that. That's my step. So x equals then 3y minus 3. So I've got one of the equations solved for x. Now I got to remember, this is the one that I solved. I got to use the other equation to substitute into. So my equation is going to be then, and again, notice how I'm going to be substituting in for x this time. So I have a negative 7, and I'm going to replace x with this 3y minus 3. And then I have then plus 8y equals then a negative 5. I can now distribute through the parentheses to remove the parentheses. A negative 21y plus 21 plus 8y equals negative 5. I have my like terms, so it's going to give me a negative 13y plus 21 equals then a negative 5. I got to put a negative 21 to the other side. So I'm going to show that. It's a little more concrete for me. I'm not real familiar with those numbers, so when I'm kind of nervous, I go ahead and show the work. Negative 13y, and that's going to be a negative 26. And I can kind of see that that's actually going to be a positive 2. So I could divide both sides by negative 13, and I would get my positive 2. So y is equal to 2. Now what I got to do is substitute this 2 back in to find what x is. And since this equation is already solved for x, I'm going to use that equation. So x is going to equal then, and I'm going to replace y with the 2. So it's going to be 3 times, and I'm going to put a 2 in for y. Substitute that in, and I have minus 3. So x is going to equal 6 minus 3, so therefore x is going to equal 3. And therefore my solution is going to be x is 3, y is 2. So 3, 2 is the solution. That's where the two lines will cross, that ordered pair. So again, we should write that as ordered pair. So why do we do all this? Well, in the real world, some problems get a little bit more difficult. And since the problems get a little bit more difficult, we need better strategies. And what we're going to do is show you how this could actually fit into some application types of things. Okay? So stay tuned for a few applications.